Hello, welcome to our presentation on Basalla's thesis and the spread of Western science. My name is Aditya and I will be giving our introduction. This presentation aims to analyze Basalla's thesis and give an evaluation on how convincing the proposition and the ideas presented are in explaining the global spread of scientific knowledge and development. We will accomplish this through the use of case studies of the development of science in former colonial territories and compare it with Basalla's proposed mechanisms to evaluate their accuracy and justify our conclusions as to whether we find his argument convincing or not. So Basalla's thesis provides a European-centric model for the spread of science, spanning from its initial spread in the 16th century right up until the Cold War period where the paper was written. And the proposed mechanism for this spread is in three stages, spanning initial colonial interactions, through exploration or through trade, right up until the independent country has developed its own scientific institutions. So, expanding a bit more on this first stage, the scientific work here is largely confined for the purposes of agriculture or exporting either spices or minerals, and as a result, most of this revolves around geology, botany, and surveying. And as a result, most of these collected works were sent back to Europe for scientific evaluation. The second stage now expands the number of scientists to include European settlers and natives who largely have their educational roots in Europe and European institutions. And as a result, most of their interests are guided by the work of Europeans, with colonial education uh, inadequate for proper scientific development. As a result, as Basalla terms it, the colonial scientist is limited in the depth of work they can do, due to a lot of European academic institutions being inaccessible and the one-way stream of knowledge, since European academic circles are less likely to consider the work of colonial scientists compared to the work done by other Europeans. And so the final stage of the diffusion of science in Basalla's thesis ultimately ends with the colonial territory becoming its own independent country, or its own independent scientific power, with its own scientists with their scientific roots based in the home country and their own prestigious institutions. And so here there's a heavy emphasis on the adoption of European scientific methods being key to reaching this stage. And so Basalla cites Japan and the United States as examples where growth was initially limited. For Japan, in Japan, for example, growth was stagnating up until the country decided to open itself up to European uh, trade and uh, stream of knowledge. And as a result, this allowed much more rapid development of science.
Now that we've seen what the Basalla model is, let's apply it to the real historical case of Australia and New Zealand. So we do see that the characteristics that Basalla outlined for the first stage really do apply in this case. So the first stage is characterized by scientific expeditions, and we have the explorations by Banks and Cook, who not only collected botanical species, they also sent them back to Europe to be catalogued and classified. So science did not apply in these new lands. These new lands were only a place where you went to collect interesting scientific artifacts, and then these would be sent to Europe where real science would happen. The second stage of the Basalla model, the colonial science phase, can also be applied to Australia and New Zealand. This is the phase when we see an expanding number of scientists working on a variety of different fields. However, all discoveries are still dependent on European institutions, as they must be presented at the Royal Society or similar institutions. The scientists are educated in Europe, and the topics that are of interest in this phase are linked to the topics that the European institutions consider relevant for a colonial settlement. So in the case of Australia and New Zealand, there was a great interest in botany, astronomy, meteorology, and cartography. And those are the sciences linked to describing and classifying findings in a new different land. And then we have the final stage of Basalla's model, characterized by a move from a scientific periphery to a scientific center that also applies in the case of Australia and New Zealand. Pictured on the right, we have Frank Burnet, who was an immunologist and virologist that refused positions at Harvard because he was interested and committed in transforming Melbourne in an international center for medical research, which he did, and he was able to attract Nobel laureates to work with him there. Another characteristic of this final stage is the establishment of independent scientific journals and native scientific institutions. One example is the Australian Journal of Sciences that was established in 1938. So Basalla would conclude that Australia and New Zealand are a successful case of the spread of Western science according to his model. By the end of the final stage, we see an independent scientific tradition, native journals, institutions, and an education system in place. And all of these institutions were modeled after the European institutions that first gave rise to them. There are a few assumptions that Basalla makes about what is science in his model. One of them is that the space outside Europe is empty of science, and proper science can only happen in Europe. Then he also assumes that indigenous peoples are mere informants and they are unable to perform proper science and don't possess any proper scientific knowledge. He also assumes that there is a one-way flow of knowledge from colonies to Europe, and all of these assumptions apply in the case of Australia and New Zealand. We see science being performed by white Europeans and all the science being sent to Europe to be analyzed there. However, one of the final assumptions that Basalla makes about science, the one that scientific knowledge is neutral of space, so it applies equally everywhere, doesn't hold as well in this case. And that is because Australia and New Zealand have such an unique fauna, flora, and geography that the science that is possible there isn't quite possible anywhere else in the world. So, as an example, Charles Darwin looked at marsupials that are found in these lands when crafting his theories of evolution. And when we look at astronomy, because Australia and New Zealand are located in the southern hemisphere, the astronomy that is possible there can't really be done in Europe. Another very important consideration, and maybe the reason why Basalla's model applies so well in this case, is that these lands were settler colonies colonized by white Europeans who exterminated indigenous peoples. So there was no need to have a dialogue with the people who lived in these lands before, as they were completely replaced by European settlers.
So we've looked at Basalla's thesis from a location point of view. Now we're going to look at it from an aspect of science, so from a medicinal perspective, and see how it fits in to Basalla's thesis. So the perception of indigenous versus colonial medicine back then was that indigenous firstly existed prior to the colonial era, but it was thought to be stagnant and unchanging and unscientific, whereas colonial medicine was thought to be the official medicine of the colonial government, was driven by science, and it was modern and innovative. Traditional Chinese, Ayurvedic, and Unani medicine were present many years before and independent of European rule, and they have evolved for over 2,000 years and are still present today. Western medicine was assumed to be superior in that it had made significant progress over the Renaissance period, and therefore aimed to displace this indigenous medicine practices. However, they both, all of them, existed alongside one another for a number of years and still do today. The very existence of these medical methods before colonial rule and the process of the gradual integration and use of Western medicine in India and China provide examples which contradict Basalla's thesis. Basalla's thesis insinuates that the space outside of Europe is empty of science, but this is clearly contradicted by the presence of Chinese and Ayurvedic medicine, which has existed for over thousands of years. And this is science, they were science because research was involved and experiment involved, and it was recorded and passed down, which fits the description of science, and it was used to heal diseases that local people had. Secondly, Basalla claims that the scientific laws and knowledge apply equally everywhere. However, this was not correct because there were many diseases that were abundant in tropical climates or due to differences in geography, population size, and cultural tendencies in Asia. And that meant the diseases were unique from infections that were found in Europe. So this clearly meant that the medical knowledge that could be applied in Europe could not be directly diffused on and used in Asia. It couldn't be copied and pasted and it wouldn't work. It had to be adapted and evolved to work in this environment. This diagram shows a town in India and with people suffering from diseases and the colonial armies interacting with them. Another point from Basalla's thesis is the thought that Indigenous people were devoid of proper scientific knowledge. However, they had that local Ayurvedic or Chinese traditional medicine knowledge that was passed down, and it did work and heal ailments and was vital in treating local diseases. And that can be classed as scientific knowledge, in which the physicians that practiced these had a lot of that knowledge with them. One of obviously the main points of Basalla's thesis is that there's a one-way flow of knowledge, or a diffusion. Western surgeons, the colony, were exposed to a range of new medical conditions and incorporated indigenous medical knowledge into Western practices, so that clearly there was a two-way flow of knowledge instead. Furthermore, medicinal plants and drugs from the peripheries were used in Western medicine, where they have seen them being used in Ayurvedic practices, and also seek the knowledge of locals who would tell them where to find these plants and how they had to be prepared in order to be effective. Again, both sides learned from one another and benefited, and there was definitely the passing of knowledge. This is one of the plants that could be used for medicinal purposes. Lastly, medicine in the colonies were thought to be motivated purely in the search for scientific knowledge. However, it's clear that there were many political, economic agendas that benefited the East India Company underlining this medicinal progress, as well as some underlying racial prejudices in the sense that Indigenous people were thought to not have the capability of understanding the complexities of Western medicine. It's safe to say that the journey into the colonies transformed and improved Western medicine because it exposed it to other diseases and plants and treatments that could not have been found in Europe. And it was definitely not a one-way transfer of knowledge.
Now that we've discussed about the science of medicine in relation to Basalla's thesis, we will now turn our attention to a case study involving two well-known scientists in colonial India, Satyendra Nath Bose and Jagadish Chandra Bose. Our first example is Satyendra Nath Bose. In essence, he developed the foundation of quantum statistics and the theory of the Bose-Einstein condensate in 1924. To give you an idea of his background, he was born in Calcutta, India, and he attended Presidency College as well as Calcutta University, where he received his MSc in mixed mathematics in 1915. In 1919, Bose co-authored the very first English translation of Albert Einstein's original papers on special and general relativity, as he was fluent in multiple languages. In 1924, he discovered a new way to derive Planck's radiation law without any references to classical physics. This fully, quote-unquote, fully quantum derivation had profound implications and resulted in a new area of physics known as quantum statistics. Based on his work, he wrote and submitted a paper to the Philosophical magazine in the UK, but it was rejected. Afterwards, he sent his paper directly to Einstein in Germany. Einstein recognized the significance of Bose's work, and he had the paper translated and submitted to a prestigious scientific journal in Germany on Bose's behalf. Einstein then extended Bose's work, and this resulted in the prediction of the new state of matter, the Bose-Einstein condensate. So what conclusions can we draw from this example? Although Bose did not receive his education from a European institution, Bose had studied the works of European scientists. And this is in line with Basalla's model, which states that a colonial scientist would have studied the works of European scientists and will have published his books, laboratory equipment, and scientific instruments from European suppliers. In addition, we saw that it was only through Einstein's endorsement that Bose's paper was accepted by a European scientific journal, after which he gained recognition. So this is also in line with Basalla's model, which states that the colonial scientist seeks the membership and honors of European scientific societies and publishes his researches in European scientific journals. On the other hand, however, Basalla's model primarily focuses on the spread of modern science from Europe to the rest of the world, whereas in contrast, in this example, we saw that the so-called periphery can sometimes be a source of important new ideas, rather than just the European center. In addition, Basalla argued that colonial science was unlikely to open new fields of science, whereas Bose's work contributed to the formation of a new field, quantum statistics. Our second example is Jagadish Chandra Bose, who pioneered the investigation of radio and microwave optics, and gave his first public demonstration of radio waves in 1895. In addition, Bose designed a radio coherer, or detector, that was a significant improvement over other coherers in use at the time. This design was used in Marconi's transatlantic wireless receiver 2 years later, although Marconi did not acknowledge Bose for his contribution. About a century later, IEEE named Bose the father of radio science, and we can see from this quote that Bose was responsible for a variety of different inventions and discoveries, and his pioneering activities indicate that he was well ahead of his time. A few things to note are that Bose's work was built on top of the work of European scientists like Heinrich Hertz and Oliver Lodge. In addition, Bose published a paper to the Royal Society of London with the help of Lord Rayleigh in October 1895. Another thing to note is that prior to his work being discovered, being recognized, he experienced various racial barriers. For example, due to discriminatory colonial policies at the time, he was denied access to equipment and lab space because of his race. As a result, Bose had to resort to conducting experiments inside his confined lodging. In addition, a colonial administrator at the time, Alfred Croft, had told Bose that Indians do not possess the requisite temperament for exact sciences. So we can conclude from this study that like the previous example, Bose's pioneering works were done in India rather than Europe, demonstrating that important scientific ideas can originate from the periphery rather than the center. Nonetheless, Bose received much of his scientific knowledge from European scientists and relied on European institutions, such as the Royal Society of London, to publish his work. In addition, Basalla's model does not fully address the politics of knowledge. For example, it doesn't really talk about the discriminatory colonial policies that could impede the ability of local scientists to conduct scientific research.
I'm Lazar, and I will briefly be discussing the transition periods between the phases as they were stated in the Basalla's thesis. So we believe it's quite important to understand the idea of these phases to understand how convincing we find this argument, even when looked at a more global scale. So the first thing we can notice, and which we already described, is that the phases do not occur sequentially. So we can see that while phase 1 is occurring, phase 2 has already begun. The same goes for phase 3. So this was done intentionally, and we can see that from this intersection that there has to be a period where two phases do coexist. So while phase 1 is occurring, phase 2 is, and so is phase 3. So to look at this more closely to see, do we find it possible for this to actually occur? So the phase 1 to phase 2 transition, when we've already described. So phase 1 being the non-scientific society provides a source for European science, while phase 2 is a period of colonial science. So as was described, so non-scientific society the Europeans would bring back the knowledge they've collected from a newly discovered area, and it's all funneled back into Europe. And we can see that that's for the benefit of the quote-unquote, well, not yet colonizer, but Europeans. Well, phase 2 is period of colonial science, which again is has a very similar goal to the phase 1, which purely benefits the European colonizer. So we can actually see that these two phases may even coexist, because it is a transition period from just purely collecting science to sending scientists to examine it more closely. However, it is very difficult to determine the timeline of phase 2, because Basalla himself has stated that the term colonial does not have the same meaning in this paper to what the colonial usually does. So it is described quite vaguely, as it is also traditionally considered colonies, but on the other hand, he also considers Russia, Japan, US, etc. as members who were under colonial science, even though obviously those countries were not colonized at the time. So it is there is a large number of different experiences and very difficult for us to determine the exact timeline. So, for example, the scientists that he mentioned, such as Lomonosov and Benjamin Franklin, it's very difficult to place them as colonial scientists, as they had a lot of influence from their own nation. Lomonosov was mostly studying in Russia, while Benjamin Franklin did originate from 13 colonies, which has turned into US at that time, and largely with his doing. So it's very difficult to see how does that have to relate with the continental UK. So this whole argument makes it a bit difficult to consider a phase 2 to phase 3 transition, as we cannot clearly determine which period phase 2 belongs to. It is difficult to then see up until which point it exists and which point does it clash mostly with phase 3. So the phase 3 being the completing the process of transplantation with a struggle to achieve independent scientific tradition, meaning that the phase 3 attempts to establish a scientific institution in the newly colonized nation. So these phases are very different from one another. They have severely different goals. While phase 2 is purely for the benefit of the economic and administrative interests of the colonizer, sort of very similar to phase 1. It focuses on the scientific benefits purely for the colonizer. The phase 3 seems to do the complete opposite, which is the establishment of a national scientific research system, which, when looked from the perspective of the colonizer, does not make much economic, administrative, or administrative sense. So it is very difficult to see that these two phases could coexist at the same time, as Basalla has described them. However, he does specifically say that colonial science contains, in an embryonic form, some of essential features of the next stage. So when we look at this, there is very little linkage between these two phases, and it does not go well with saying that phase 2 is meant to encourage and start developing the next phase. So from this, we can see that the model may have tried to oversimplify things to try and make them applicable in all scenarios. But if we consider it if we step back and actually consider this, it does not seem to hold up very well.
In conclusion, we do not agree with Basalla's proposed thesis. Through our arguments and case studies, we have taken issue with his proposed models and his assumptions. While his model does contain accuracies, for example, Bose was reliant on European education and European institutions for recognition, we have found counterexamples to his proposed one-way stream of knowledge. For example, the discoveries in medicine that have been made from local knowledge, as well as his failure to take into account issues such as European discrimination, as well as his oversimplified three-stage model. Basalla's model also fails to evaluate the scientific discoveries and the influence of the periphery to sufficient depth in order to justify his model with Europe being the sole source for the diffusion of science. Thank you for listening.